Today we will be doing class 7 physics, and the topic for today is sound. So you can hear sound everywhere, isn't it? You can hear my sound, you might be hearing the sounds that are around you when you're watching this video. You hear sound like when you're on the bed, and when you do not want to, are in a deep sleep, and you hear sounds around, isn't it? So you wake up because of that sound. So it's raining right now and we can hear that sound. So sound is everywhere. As long as your ear is functioning well, you can hear the sound, isn't it? So today we will be discussing how sound is produced and what are different, how does it transfers, okay, how is sound transferred, how is sound produced, and many more. So first, let us define what is sound. So sound is a form of energy that gives us a sensation of hearing. That means because of the sound we hear things. Okay. So the function, it is because of the sound energy that our ears function. We know the function of the ear because of the sound energy. So sound actually travels in the form of wave. So before we start, let's define sound. How is sound created? Sound is created or produced when an object vibrates. That means if there is no vibration, no sound will be produced. It depends upon the type of vibration. If the sound is very mild, if the vibration is very mild, the sound produced will be very soft. And if the vibration is more, then the sound produced will be loud. So depending upon the type of vibration. But there will be vibration. If there is no vibration, no sound will be produced. Okay. For example, if I hit over here, we hear the sound, isn't it? Why? Because when I hit over here, what is happening? The stick vibrates. Okay. Even the particles over here, they get vibrated. So we hear the sound. I bang on this desk. What is happening? We hear the sound. Because here the stick, it vibrates, and the particles around it also vibrates. Okay. So because of the vibration of the particles, we hear the sound. For that, you can try an experiment. What you can do is you can get a drum, okay, and then put some rice grains on top of it, and then you start beating those drums. What will you see? You see those rice grains, they'll start jumping up and down. So what is happening actually? It's because the membrane of the drum is vibrating, and along with it, because it's vibrating, it's also disturbing the grains around it. So the grains will also start jumping up and down. Okay, that is one experiment to show that vibration produces sound. A sound is produced because of the vibration of the particles. Now, sound is a wave of vibration that spread from its source. Vibration. Now, before we talk about the actual definition of sound, you know what vibration means, isn't it? We have done this in the previous chapter. I think that was the first chapter that we did. That is your motion, and in which we learned what is vibration. So what is vibration? Very fast to and fro movement, isn't it? So when the particles move forward and backward very fast, we call it vibration. Okay. So vibration is the back and forth motion of an object. Is the back and forth motion of an object. And sound, a wave of vibration that spreads from its source. So whatever produces sound, okay, the sound, what happens? It travels in the form of wave and reaches the air, okay, of a human being or animal. Okay, this is very important. As I told you already, why are some sounds louder than others? This one will be defining more when we will be doing the characteristics of sound. But as of now, just understand, I've told you this already. If the vibration is very fast, then the sound produced will be loud. If the vibration is slow, okay, or low, then the sound produced will be soft. And the unit for measuring sound is called decibels. Okay, the unit used for measuring sound is called decibels. So a sound's loudness can be measured in units called decibels. So this is how sound is produced. Okay, this is how the particles travel. Now sound is created when sound waves bounce off an object and vibrate against it. Now the particles, this is how the sound would be travel. Okay, this is how the sound wave moves. The particles, they start vibrating to and fro. They start vibrating to and fro, and when the particles vibrate to and fro, it touches the other particle. Now the second particle starts moving to and fro. Again it touches the third particle. Again it starts vibrating to and fro, and this is how it reaches the air, okay, or the from the source to the ear. Okay. So we'll be showing you now. Before, as we discussed, the sound is a form. It travels in the form of wave. Now there are two types of wave. Before we discussed how sound is produced, okay, and how sound travels. Let's discuss there are two types of waves. One is transverse wave, the other is longitudinal wave. Okay, one is transverse wave, the other is longitudinal wave. The transverse wave means when the particles move up and down. Okay, transverse wave means when the particles they move up and down. This is how they travel. Okay, so you've seen the waves of the ocean, isn't it? Exactly that way. That is your transverse wave. Okay, so how does the wave of the ocean move? It moves up and down. The same way the particles move up and down in transverse wave. In longitudinal wave, the particles move to and fro. That means it moves forward, it goes back. Again, when it moves forward, it touches the other particle, it goes back. Now this particles vibrate, moves forward, goes back. And then the series continues. Okay, that is your longitudinal wave. And sound travels in the form of longitudinal wave, and light travels in the form of transverse wave. So this is how sound wave travels, this is how light travels. I'll be explaining you furthermore, but first let's understand what are the different types of waves. Transverse wave and longitudinal wave. Okay, so transverse wave, this is how they move up and down, like the ocean, like I told you, the waves of the ocean. And this is how longitudinal wave moves to and fro. They move up and down. Now, for transverse wave, okay, when they go up, when a transverse wave passes to a material, individual particles of the material move at right angles to the motion of the wave. So this is your right angle. And longitudinal wave, they move parallel to the direction of motion of the wave. So parallel, this is how they move, and this is how the transverse wave make. So transverse wave make an angle of 90 degrees to the motion of the wave. The wave is moving this side, isn't it? The wave is going in this direction, which means it's moving straight, but it's moving up and down. That's why it makes an angle of 90 degrees. Whereas for a longitudinal wave, it travels to and fro. That means in the same line. That's why a longitudinal wave moves parallel to the direction of the motion of the wave. And they both transfer energy, but they transfer energy in different ways. Now see here, transverse wave and longitudinal wave. Now transverse wave, when they go up, the highest point when they reach this, when they go up, okay, when they form the curve up, that is called crest. And when the same way, when it comes down and forms a valley, this is called trough. Okay, when they move up, this is called crest, C-R-E-S-T, crest. And when they move down, it's called trough. Okay, so transverse wave form a series of crest and trough, crest and trough, crest and trough. So this is how they move, up and down. So upper part, that is called crest. When they move down, that's called trough. Okay, that's your transverse wave. Now longitudinal wave, as I told you, it moves to and fro. So when they move to and fro, what happens is when they come closer, that is called they call compression. When they compress together, when they are together, that's called compression. And when they get back to their normal position, that's called rarefaction. You might be thinking I'm stupid because I'm laughing over here. Some of them are making me laugh here. for that. Okay. So a series of, when the particles they come together, as I told you, when one particle vibrates and then touches the other particle, they come together for a while, isn't it? So when they come together, we call it compression because they are compressing each other. When they go back to the normal position, that is called rarefaction. So dense part, when they come together, that is dense part, is called compression, and when they are thinner in the normal position, it's called rarefaction. Now the difference between comparison between transverse and longitudinal waves. Transverse wave and longitudinal wave. Transverse wave, the particles they vibrate up and down. Okay, so the particles move up and the wave in which the particles move up and down. Longitudinal wave in which the particles move to and fro. Okay, transverse wave, I told you, they form a series of crest and trough. Crest and trough. And longitudinal wave, they form a series of compression and rarefaction. Compression and rarefaction. Okay, some of the examples over here. Surface water waves, waves on a stream. Okay, electromagnetic waves. Example would be light waves. And for longitudinal waves, sound waves. Okay, sound waves, seismic waves. The seismic waves means the waves of when how earthquake comes, isn't it? So these are the differences between transverse wave and longitudinal wave. Transverse wave make an angle of 90 degrees with the motion of the wave, whereas longitudinal wave is parallel to the motion of the wave. So I hope you understood what is transverse wave and longitudinal wave. Okay, so this is how transverse wave, this is how sound will be produced now. See, this is your tongue over here. Now when you vibrate it, when the tongue vibrates, what happens? The particle starts moving and they come closer. When they come closer, when the particles come closer, it's called compression. It touches the other particle. The other particle, when they are in the normal position, is called rarefaction. Okay, so longitudinal wave forms a series of compression and rarefaction. So today I'll stop over here. I've just introduced you with transverse wave and longitudinal wave. In the next class we'll be learning how to produce sound, how sound is produced, okay, and in what way the particles will be transferred. Thank you and have a good day.